All right. Another way to find the zeros of a cubic function is by using synthetic division. Remember, we use synthetic division in class to check if a polynomial was indeed a factor of the function. So we were actually able to use synthetic division. If the remainder came out to 0, well, that would tell us that the thing that we were dividing by was indeed a factor. But those problems all had chosen the divisor for us. Now it's on us to come up with what we want to divide by to check and see if it is a factor. So what we're going to do is we're going to do a little look at this last number. We're going to look at 6 and think about what are all the numbers that fit in there. I've got 1 and 6, I've got 2 and 3, and in fact that's the end of my factors. What we know is that when we get down to the 3 factors at the end here for this cubic function, that the constants in them are all going to be factors of this 6 by nature of the fact that we multiply those together to get this 6 at the end. We know that it's going to be one of these 4 numbers, either positive or negative, in each of our final factors. So what we can do is we can set up our synthetic division. So we can set up a bracket. We're going to bring down those coefficients. So 1, -4, 1, and 6. And we're going to start trying some out. So if I was going to divide by x, let's say plus 2, I'm going to bring the root down here. So it's the opposite of whatever was in that group. So if I have x plus 2, I'm going to bring -2. Then we're just going to do our bring down, multiply, add, and kind of go through that process and see if there's any sort of remainder. So let's say -2 times 1 is -2. If we add those together, we get -6. -6 times -2 is positive 12. We get 13, and we can start to pretty much already see, yeah, this one's not gonna work because we don't get a nice remainder of 0. We get -20, and we have some sort of remainder there. So that one didn't work. So let's try another one. Why don't we try x minus 2? For this one, we're going to bring a positive 2 down. Do the same exact setup. So bring this 1 down. 1 times 2 is 2. Add those together and get -2. 2 times -2 is -4. Adding these together, we get -3. 2 times -3 is -6. And 6 plus -6 is 0. So here we have found one where, hey, there is no remainder here. No remainder. So that tells me that what we were dividing by, x minus 2, is a factor. So if we come down just a little bit, we can rewrite this original as the multiplication of x minus 2 multiplied by whatever we got as our quotient. So we got 1x squared, remember, because that shifts over. If we start with x cubed on the bottom, we get x squared. If we had x squared up here, we have x underneath. If we have x up here, we have our constant below. And if we have our constant up here, we have the remainder underneath. So we actually get x squared minus 2x minus 3. And again, we have one factor that has x to the first power, or first degree. We still have a quadratic here. We still have an x to the second power that we want to figure out how to factor. And again, we can fall back on any of the things that we've learned so far. We can do quadratic formula, we can do factoring, we can do any number of things here. My first look, again, is always a, b, and c. Let's see, b is -2, c is -3. And I ask myself, is there anything that multiplies to -3 and adds to -2? And yeah, there is. -3 and positive 1. So we can actually rewrite this as x minus 2, x minus 3, and x plus 1. And there's our final factored form here. And yeah, look, it checks out because we said we were going to get this 6 at the end. And if we have -2 times -3 times +1, we get +6. So it definitely worked out. The only thing left to do is say, well, my zeros, my x-intercepts are going to exist when y is 0. And so I have to think about when these factors are equal to 0. So let's see, it could be x equals +2, it could be x equals +3, or x equals -1. There are our zeros, our x-intercepts. All right, good luck.